Welcome to the Explainer. Look, if you're leading a product or engineering team right now, you are literally standing on the edge of the biggest shift in software development since we invented high-level programming languages. We are rapidly moving away from manual coding and diving headfirst into the era of intelligent agents. But as we're going to see today, that transition is causing a ton of hidden chaos. So, let's dive right in and explore this urgent paradigm shift facing your engineering teams today, and more importantly, talk about how to actually get it under control.
Here's what we're going to cover today. We'll look at the new AI reality, dig into the split constraint, talk about the vibe coding trap, and then lay out a concrete playbook for you. Spec-driven development, formatting for the machine, and finally, the factory model.
All right, part one, the new AI reality, and specifically the massive scale of AI adoption we're seeing in early 2026.
Let's just start by establishing an absolute fact. Using AI to code, it is no longer some futuristic concept. It is the unavoidable reality for engineering teams right now. In fact, as of early 2026, a staggering 85% of professional developers are regularly using AI coding agents. That means practically your entire team is leaning on these tools every single day to get their work done.
And because of that massive adoption, we're seeing something wild. About 41% of all new code is currently AI-generated. Just pause and think about what that really means for your repositories. There's an unprecedented volume of code hitting your codebases right now, and the machine is doing the typing.
So this is creating a foundational shift in our industry. We're moving away from simply writing code to expressing intent. Developers aren't just typing out syntax anymore. They are dictating architectural intent to highly intelligent systems. The machine figures out the how, but the human is entirely on the hook for the what and the why.
Moving on to part two, the split constraint. Where did the engineering bottleneck actually go?
Okay, so if AI is writing nearly half of all our code in seconds, you have to ask, where did the bottleneck go? Because it certainly didn't just magically disappear, right? It relocated. There are actually two Google papers in 2026 that completely disagreed on this. One argued the bottleneck moved entirely downstream to human code review. The other argued, nope, it moved upstream to specification writing. Well, it turns out they were both right. The constraint literally split in two. Your developers are now squeezed between writing these hyper-detailed specs up front and then painstakingly verifying whatever the AI spits out at the end. Which brings us to part three, the vibe coding trap, and why teams are actually slowing down.
This split constraint leads us straight into a huge pitfall. It's the hidden debt of casual vibe coding. That's what happens when developers just loosely prompt an AI, see that it kind of works, and ship it without any systematic verification. Now, industry surveys are throwing around these big numbers, reporting 25 to 39% general productivity gains. Sounds amazing, right? But hold on. A recent meta-study actually found that experienced developers took 19% longer on some tasks. Why on earth would they be slower? Because of the massive amount of verification time required to debug and correct unconstrained AI outputs. When you let the AI guess your intent, you're absolutely going to pay the price in debugging.
So to actually survive in a production environment, your teams have to navigate this conceptual spectrum. Over on one side, you have vibe coding. It's casual, it's fast, it's disposable, but there's incredibly low verification. You absolutely must evolve past that toward true agentic engineering. Because the differentiator today isn't whether or not you use AI, it's how rigorously you verify its outputs. We're talking formal specs, automated evaluations, and strict CI/CD gates.
Let's dive into part four, spec-driven development. This is the cure for that split bottleneck.
So how do we actually get to that rigorous verification? By adopting spec-driven development. Think of a production-grade spec as your architectural North Star. It's there to prevent context fragmentation. That digital game of telephone where the AI just completely loses the plot. Your specs need the full technical design, not just vague bullet points. They require visual aids and, crucially, strict library version numbers so the AI doesn't start hallucinating outdated packages on you. You've also got to include background context on the why, along with explicitly defined scenarios and edge cases. You simply cannot let the agent guess. And to write those scenarios effectively, you really want to lean on behavior-driven development, or BDD. BDD uses structured natural language, specifically the Gherkin syntax of scenario, given, when, then. This state-action-outcome structure is an absolute game changer because it completely constrains the agent. It tells the AI exactly how a system has to behave from the user's perspective, completely cutting out the guesswork of vibe coding.
But how do you know if your spec is actually any good? Enter the regeneration test. Here is exactly how it works. You take a working module, you completely delete the code, then you hand a fresh, clean AI agent only your spec, and you see if the brand new code it generates can pass your existing test suite. If it fails, that gap between failure and success, that is exactly what your spec is missing. And a quick warning here, if you leave your specs unowned, your testing harness is going to drift until the agent's behavior just stops being reproducible entirely.
All right, part 5, formatting for the machine. Why the shape of your spec matters just as much as what's in it. Here's something a lot of people miss. Writing a great spec isn't the end of the story. The actual format you use impacts the AI's ability to reason. Remember, large language models don't read the way you and I do. They process tokens. Data from the 2026 SKCC study on skill compilation is super clear on this. For deeply nested logic, so anything with a depth greater than 3, YAML drastically outperforms JSON and XML in parsing accuracy. We're talking almost 52% accuracy for YAML, while XML tanks to under 34%. If you're using heavy JSON or XML, you are literally taxing the agent's reasoning capacity.
It gets even crazier. That same Sketch study found that using generic, unoptimized Markdown files can cause up to a 40% performance penalty in AI agents. So, what's the fix? You need a hybrid approach. Use clean Markdown headers to anchor the agent's attention for your narrative instructions, but the second you get into structured configuration or deeply nested schemas, switch immediately to Llama. This hybrid approach gives you optimal token economics and keeps the AI strictly on the rails.
Finally, part 6, the factory model, building the system that builds software. To pull this whole thing together, engineering leaders have got to completely shift their team's mindset to a factory model. You are no longer manually building software. You are building the system that builds the software. Think of the AI model as just a raw engine sitting in the middle of a factory floor. It can't manufacture a car all by itself, right? The developer is now the factory manager. Their job isn't manual assembly anymore. Their job is designing the assembly line. They define the specs, they set up the guardrails, they build the testing harness, and they place the safety sensors.
So what should you take away from all this? Here are your immediate next steps to get your team out of the vibe coding trap. First, mandate that your team shifts their focus to structured, well-formatted spec writing. Second, get those automated evaluations in place. You have to test not just what the agent built, but how it got there. And third, adopt human-in-the-loop fail-safes for anything high stakes. Let the agent do the heavy lifting for sure, but the human always signs off on the architecture.
Which leaves us with this one final thought. The typing part of programming, it's largely solved. The machine can generate the syntax. But if code generation is solved, is your team actually ready to master verification, judgment, and direction? Because let me tell you, in this new era of agentic engineering, that is the only skill that truly matters anymore. Thanks so much for joining me on this explainer, and I'll catch you next time.